Hello, geometry students, and today we will be looking at 5.4 day 2. So just kind of an expansion on yesterday where we added in more of the angle side angle and the angle side. So really all you've got today are proofs on your homework. I think there's 9 questions on your homework. I think if I'm remembering correctly, there's going to be 3 of each of these types of diagrams that we're looking at here. So just kind of getting some more practice with the proofs. So starting out with this first one, remember, especially on these ones from yesterday's work, you're definitely going to want to redraw those with some scratch paper so you can see those triangles kind of torn apart and separated from being overlapped. So starting off here, our goal is to prove triangle ABC congruent to triangle EDC. And let's start off again, like we always do, with the given statement. So the first one, AC congruent to EC, and the second statement is the fact that angle ABC congruent to angle EDC, both those being given statements. So we can mark those two down on our diagram. So AC congruent to EC is going to be right here. ABC congruent to EDC are those two angles. And now again, looking at what is the diagram giving us that we can go ahead and prove, and maybe that will lead us to one of these congruence theorems, right? So we should be starting to kind of see some patterns of what kind of diagrams we're seeing. Here, you're given a diagram that has those vertical angles in the middle, those kissing angles, and you always want to state that right away. And when you're done with your givens, as soon as you've got that, whether that's the last step you need or not, take advantage of the congruences that they're giving you in that diagram. So we know those two are going to be vertical angles. So let's go ahead and name those with their corresponding parts. Let's call that first one ACB. So angle ACB. Whoops. And then that's going to be congruent to, and we want to name this correspondingly. E is correspondent to A there, so then ECD. Angle ECD would be the correct name for that next angle. So those two are going to be congruent because they are vertical angles. And we know that vertical angles are congruent. So we've got right now one angle, another angle, and then a side of congruent pieces. And so we're going to go ahead and we're going to be able to send to proof. So this is only going to take one more step. You only needed to add one in there between the givens and the proof statement. And then we've got triangle ABC congruent to triangle EDC. And they are congruent by the angle side theorem. And that one's done. Okay, now as we had mentioned, with these diagrams here, you're definitely going to want to separate them. So what are the triangles they're talking about? Well, triangle PQS. So PQS. Ooh, I want to try and do this nicely. Okay, whatever. That's as good as I'm going to get it. And then RSQ. So when we've got those, again, not going to let me move that stuff. Good enough. So we're going to separate these triangles. So these are the triangles that we are going to take away from that overlap diagram so we can see them a little bit better. Okay, so that one in red is the S up here, Q over to the right, and then P, then that triangle in green with the R, the Q, and the S. So this is going to make you, or allow you to see these things a lot more easily. Now, again, a lot of this is getting used to the tendencies, getting used to the things that we are seeing repeatedly. So first of all, statement 1 and statement 2 going to be the givens. Again, notice that they're stating that these things are equal. So PS is equal to RQ. And then they're also saying that angle 2 is equal to angle 3. Now remember, we can't necessarily mark those as congruent because we haven't stated or proven that they're congruent technically. Now you guys might be saying, well, equal is congruent. Yes, you're right, but that has to be clearly stated. So we have to go ahead now and say, okay, well, with my third step, I'm going to say, since PS is equal to RQ, now I can say that the segment PS is congruent to the segment RQ. And that is going to be the definition of congruence. So that does have to be stated. Okay, so we can mark that now, PS to RQ. So those two sides, and then angle 2 to angle 3. So I'm actually going to change this to be more accurate here. Because when you state angles equal, it's the measure of those angles that are equal. And then when the measure of two angles are equal, that's when you can say that the construct of those angles are congruent. Again, with the definition of congruence. So, once we mark those, if we notice here, so angle 3 is that angle from P through S to Q. So that's right here. And then angle 3, or excuse me, that was angle 3. Angle 2 is that angle here from R through Q to S. So RQS. So those are your two angles that'll end up congruent. Again, much easier to look at on your separated diagram. Right now, we might be a little out of sorts in what we're seeing in that combined overlap diagram. So with the overlap pictures, you're definitely going to want to redraw those. Well, as of now, we've only got two of these congruent pieces. Well, if you remember, when we're looking for that third, or we're looking to see what this diagram is giving us, if you remember from what we saw yesterday, was with these overlap diagrams, you're typically going to have either an angle or a full side that is shared between both triangles. Well, it might be easy to see, or easier to see, by actually tracing your triangles out again and looking for if there's anything completely overlapped. And if we notice that SQ side is fully in both triangles, okay? So that SQ side right here fully belongs to both those triangles. That is going to be the side that they both share. And when you name something congruent to itself because it's within both shapes, that is that reflexive property. So we're going to be able to say that SQ is congruent to SQ because of the reflexive property, saying that something is congruent to itself. Okay, and then to finish up, we'll go up and check out what order we're looking at here. We have an angle, excuse me, it's not an angle. We have a side, we have an angle sandwiched in the middle, and we have another side. So not necessarily all going to be angle, angle, side, or angle, side, angle today. We're ending up with side, angle, side in this situation. So triangle, what were they named? PQS and RSQ. PQS is congruent to triangle RSQ by the side, angle, side theorem. Okay, so with these diagrams, a couple things. Draw those things separately. Separate that overlap so you can see it a little more clearly. And then be on that lookout for what are they sharing. There's something that they're going to share. Is it a side? Is it an angle? And then the last example of stuff we're looking at here today goes back to our situation with parallel lines. Okay, so let's start off getting these givens out of the way. So BE bisects AD. So BE bisects AD. That is given. Now, we are going to have to state this explicitly later in the proof, but let's just draw this on here so we know what that is actually doing for us. So if BE is bisecting AD, they're telling you that this side AD is being cut in half. So they're telling you that you have two congruent pieces there. Now, we can't just go ahead and assume that yet. We're going to have to state that that's true, but just to put on the diagram to understand this, this is what that bisection is doing for you in your proof. So we'll have to state that here in a minute, but we do have that ready for us. So then AB is parallel to DE. AB is parallel to DE. So that is going to be given as well. All right, so let's just go right ahead. Remember, take what this diagram is giving to you. So since BE is bisecting AD, now we can go ahead and say that AC is congruent to DC, and we want to name that with corresponding. So AC is congruent to DC, and that's by the definition of bisector. I think that's what that's going to do. I guess I'm not 100% sure on what the actual terminology on Alex would be. Definition of bisector, something along those lines. But now we have that information. So then, again, coming out of those given statements, we didn't have any congruent pieces. So we got to find all those pieces. We just found the first one. We found that side in the first one. So now remember, don't try to piece things together just by looking around. Take what the diagram is giving you. Something that should be very obvious, jumping out right now, is we have vertical angles. So let's go ahead and label these vertical angles as congruent. So ACB will be our first one. So angle ACB is going to be congruent, and then we want to do corresponding, so then DCE. Angle DCE. And that is vertical angles are congruent. Okay, so now we found two of those on our own. Okay, so just to revisit here, let's kind of clear this up so we can a little bit more clearly see what we're looking at. We have these two sides congruent, and we have these two angles congruent. Now, let's think about what else they told us. They said that AB is parallel to DE. So if those two are going to be parallel, that all of a sudden brings in our transversal conversation. Either there diagonally or this one diagonally. Either one of those is creating a transversal for you. So with transversals, let's go ahead and just keep the one that we have drawn on the screen. So if this is your transversal, then I've got a few different ways that I can be finishing this up. Wow, how did that happen? I've got what we call alternate interior angles. See how we're kind of finding these things coming up further down the road. We talked about these a while ago, but here we can now say that angle BAC, so let's go state that, angle BAC is congruent to angle EDC. And that is going to be true by opposite interior angles. Okay, and then once we have that, I'm almost out of time on the video, so I'm going to wrap this up quickly. We have an angle, we have a side, and we have an angle. So these two, ABC and DEC, ABC congruent to triangle DEC by angle, side, angle. Okay, so keep working, keep doing a great job. You've got a handful of proofs today, and have a great rest of your day.